So now we're moving on to the next talk, moderated by Benedetta Nucci. Welcome. And she's going to be moderating the session on design for circularity in the automotive sector, and also looking at strategies for improved sustainability. Benedetta Nucci she's the Senior Manager for Mobility and Lifecycle Assessment at European Aluminium, and she's an expert on lifecycle assessment and environmental impact, footprinting, and also she has worked as a policy officer for the Commission, or at the Commission. So I'm very happy to see you here.
Thank you.
There you go.
Thank you very much, and good afternoon, everyone. We have had a very interesting morning so far, and a very interesting discussion just now on the role of critical raw materials for empowering Europe's green transition. But now it's time to move downstream, and we will discuss during this panel what are the current strategies of the automotive sector to move towards increased sustainability and increased circularity. So, since the topic is so exciting, I will not spend more time in talking, but I would like to give the floor to our speaker. And to kick off the discussion, it's my pleasure to introduce you Simon Buckingham from Volvo Cars. Please, Simon. Simon is technical leader for sustainable materials at Volvo Cars, and today will talk to us about the sustainability and circularity strategy in place in your company, right? And hopefully you will tell us something more about how which role aluminium is playing within your company. So, floor is yours.
Okay, thank you. I think I'll use the lectern mic. That's okay.
Thank you.
It's even my slides, fantastic. So, good afternoon, everyone. Thank you very much for inviting me, first of all, to present, and also congratulations on this project. I've been really impressed what I've heard today, and I think a job well done for everybody. And it kind of connects into the one of the key messages in my talk. Something else as well, I think that's really important. I took a walk around the museum at lunchtime, and I found a Volvo Amazon in there from 1969. So I think it's okay for me to continue with my talk this afternoon. Okay, let's hope that this is functioning. Yes. So a bit of context, first of all. What is Volvo Cars? Volvo Cars has been on a tremendous journey over the last decade or so. And we are now a truly global automaker, selling in major markets all over the world, and also, importantly, with production facilities all over the world as well in our major markets. And I'll come on to that more later. I think that's important to give that context, because that's been a big change over the last decade or so. And recently, we've updated our sustainability strategy. We've had a very powerful strategy in place for, more than 6 or 7 years now. But we've taken the steps to sort of say, okay, where are we at? What are the opportunities? And where can we push further? So I want to dig into that a little bit. We've reinforced some of the ambitions that we previously stated. And I think what's important here is that they're very measurable and they're time-bound. This isn't fluff. This is about what are we doing, where are we going. And it's a clear signal, I hope, to the supply chain and the innovators in the audience about what we're trying to achieve. So for us, we're going full electric. Clear commitment there, half of vehicle sales by 2025, and to be a fully electric car company by 2030. That is driving significant CO2 reductions per vehicle, particularly in the use phase, but we're also working hard on the material side, and that's what I'm going to dig into today. And that is allowing us to be a profitable business and generate good revenue as well. But why sustainability? Why is that important? Is that just because we think it's a nice thing to do? And I can say from a very personal perspective now that when I joined Volvo Cars, I picked up my family and I moved from the UK to Sweden. I didn't do that lightly, and that's because the company that I joined really is fully committed here in this space. I think it really started back with the safety belt, and then the lambda sensor and these technology innovations that really affected people. And when you sort of project that forward and you think about that safety focus, it's very easy to start talking about planetary safety and the environment that we all share. So this is really at the heart of the business, but it's good business sense as well. So if we're going to do this, I mean, there's obviously an ethical need here. We must act. We have one planet. But this is also about access to finance. It's about meeting regulatory demands. It's about being a sustainable business in the long term. And that circularity piece especially is driving an expectation that we have for increased profitability. So we're seeing good for the planet, good for the business, not a trade, not either we do this or we do that. We think and we believe that we can get both. And we need some help along the way to do that. So we're really aiming to be pioneers with what we're doing. We're working towards this net zero future 2040 goal. And the circular economy is a really key enabler along in that journey. And again, how does that product that we're producing affect then positively people's lives? We view the sustainability space through this lens of these three pillars. So we talk about climate action, circularity, and responsible business. And again, we have to work to knit these all together. And the materials part that I'm working with every day connects across all of three pillars as well. So we're on this journey to transform to pure electric car company. And as you'll see from the life cycle assessment in a couple of slides' time, when you do that, what's left is the materials. And if, like me, you're someone that's focused on aluminium and steel for most of my career, it's a pretty sobering case because, yeah, we're on the podium, let's say. And we need to work on our operations as well. From a circularity perspective, it's about decoupling fundamentally. So how do we drive down that primary resource consumption? And that terminology is very carefully selected. We're not talking, in this case, about recycled content. We're talking about using less primary. We can debate about categorization of scrap and so on, but using less primary is fundamentally the goal. Obviously, we need to reduce waste and pollution and grow that circular economy business. And that's a system change of which we are part of the overall solution. So we cannot do that in isolation. It's about connecting across our supply chains in the areas that we're active in. And of course, on the responsible business side of things, again, that connection to societal impacts and you know, people working in those supply chains and being affected by those supply chains. We have to look at the human rights and safeguard those. Employee well-being is key. And basically, how do we contribute through those activities to a sustainable society? So it's not just, you know, technically what's got the lowest CO2 footprint, let's go with that material. It's about looking at these broader aspects, including access, scarcity, and price volatility, and these broader macroeconomic factors to make the right material choices. With all of these pillars, we've actually set very, very clear requirements, and I draw your attention in particular to the circular economy one here, where for 2025 we've stated for some time now that we will have a target around 25% recycled or bio-based content in the vehicle. That's on average for all new vehicles. And we've actually looked at our progress there, and we've looked at, you know, the signals we're getting from the market and what we think might be possible with a bit of stretch in there. And we've actually increased that to a 35% target for 2030. And aluminium is obviously a key contributor in that journey as well. Last week, we released the life cycle assessment of the EX30. And this is part of an interesting and I think important journey for us about transparency. So right now, we're part of the problem. Our vehicles produce, you know, consume CO2 in the production, or produce CO2 in the production phase, and then in the use phase, we're emitting CO2 as well. And I think by taking the steps that we've done, starting with the XC40, to actually produce and publish life cycle assessments, we're very clear about the methodology, we're very clear about the assumptions and the data that we've got, but to actually say, this is where we're at, this is what we do with our vehicles. So we have that benchmark, we can show how we're moving forwards or not. We are at the moment, this is very good. The X30 has the lowest footprint of any vehicle to date. We keep doing that, we put it in the public domain, and we ask for support. This report, for example, we've adjusted the methodology, we've added a maintenance phase into this, we've also got this third-party certified as well. The key things to take away here that really with this journey to electrification, we can, with the right energy mix, we can reduce the footprint in the use phase to close to zero. We can really reduce that dramatically. But what's left basically is the materials. That's what we're showing on the left-hand side. On the right, the breakdown of the CO2 impacts relatively from the different materials. Batteries is number one, steel is number two, and third place, just getting that bronze medal on the podium there, is aluminium today. And this is actually significantly changed from earlier LCAs where we've been working so strongly with steel and aluminium, and we've reduced the footprint there. So if you look at the XC40 one, you'll see that aluminium was 30% of the material footprint. So we are making progress here, but we are not where we want to be yet. But aluminium, looking at that specifically, take this study which I think was done with European Aluminium and the Ducker report basically is looking at aluminium demand into the future, and I think has been discussed several times today in the conference that basically aluminium demand is growing and content will increase in passenger vehicles. We see the same trends as well. So we have a material here that is growing in importance, and obviously as a result we need to really focus in on what the requirements are. So how do we do that? And from our side of things, that really relates to how we develop our products, how we specify materials, what would we focus on, how do we source them? We just heard in the previous talk about how the sourcing can make all the difference to the impact that the material can have. And we need to do that with our partners and suppliers. And again, I want to highlight that we don't make these materials. So we cannot engineer our way out of this in some way, just come in and do a few extra hours on Saturdays or something. We have to do this as part of a collaboration with our supplier partners to help us get to where we need to be. But our side of the bargain, I think, is setting a clear demand signal and being very open and transparent about what do we expect. So we've done that in a number of different ways. So we've engaged with World Economic Forum, First Movers Coalition around aluminium. We work with the IAI Fast Forward Zero 2030 group as well. We've set requirements around the recycled content for aluminium. That's at a vehicle level on average, but we've also gone further and looked at different applications, different product forms, and then broken it down further. So we've got target setting that actually reflects what the art of the possible is there. There's no point having requirements that are easy to exceed or cannot be met. So we've really broken that down. And then for the primary that we do get in the vehicle, we've set a very challenging target about the CO2 intensity there as well. So the emphasis is on moving to increase the recycled content but saying where we do have primary content, let's make that as least impactful as possible. And all of this, of course, we need to understand where is it coming from. We're a global business. We have production facilities in the US, in Europe and in China, and we make global vehicles, so we type approve once and you get one car that is sold in all markets. It is not differentiated. And we have a procurement strategy where we basically we build where we sell our vehicles, so we have those plants are in our major markets, but we source where we build, so we localize those supply chains. So whilst I'm talking to a very European audience today, if we're going to fix this, we need to fix this in all regions as well. So I think also, I probably don't need to preach to the choir here, but CO2 and climate action is, of course, a key focus for us, but it's not just about that. And as we learn more and we develop our requirements more, we recognize that we need to go further. And this is the journey that we're on, and I think many of you are probably learning more around these as well. But we're digging into component and material value retention. How do we measure that? How do we drive and improve that? How do we select alloy grades that are better tolerant to tramp elements? A great topic for this forum. How do we reduce energy consumption? Really taking things back to first principles. How do we work with biodiversity? It's not just about, as I say, CO2, but water consumption, land use. How are the materials that we're selecting affecting these impact categories as well? Because that ultimately is part of the wider impact that we're having. And then, of course, the ethical and responsible business side. What about indigenous rights? How do we assure that our supply chains are free of forced labour or child labour? So these are really critical parts that connect to that broader picture around material selection. My early part of my career was very simple. It was cost, weight, performance. It was quite simple. Now we load on all these other factors that are really important in order to make those right choices. So just a couple of slides, but I want to talk about the supply chain resilience, and this is really where we can come together. We have some suppliers in the room. But for us, it starts with transparency here. We need to understand how the supply chains are configured, who's in those supply chains, and not just the tier one. It's across the whole supply chain back to the source. When we know that, how do we trace the product through from the source to our vehicle, so that we can actually make a product claim then and say that, yeah, we did the right thing. Here's the product over here. This is what's in the car. We're moving forward, we're doing the right thing. We're meeting legislative requirements, for example. We're meeting our ambitions. And part of that also connects then to the certification side. We need something that's globally recognized, standardized so we can compare, but also third-party audited. We need real boots on the ground, so people have been and checked and we know things are okay. This is really crucial. So, how do we get there? It's a really simple message. We need to connect and work together on this, and I think the SALEMA really shows that. This is seeing different organizations with academia or in the industrial side of things working together across countries. This is so crucial, and we need that help as well, because we cannot solve this on our own. We're making great steps forward, but we need your support to really get to where we need to be. So thank you. I'll end there.
Thank you very much, Simon, for this presentation. A lot of food for thought, I must say. So
now I leave the stage and there are no questions, right?
I have a long list of questions, so I actually hope the public doesn't have any, but let's see. So okay. From my side, what I can say is that personally, I really appreciate the fact that you remind us all that there's not only climate change. That's great, and how collaboration is key when we tackle this kind of problem. And yes, indeed, SALEMA is a great example. But now I would like to open the floor for questions. Is there any question that you would like to raise to Simon? Yes? I saw a hand like next in front of you, Francesca, right? No? Okay. Christian, and one there, yes.
Okay, so thank you, Simon. A very interesting presentation. A technical question. You mentioned these 4 tons of CO2 per ton of primary. Is it cradle to gate emissions? Because it's a very challenging figure, but okay.
Yes, you're right. It is very challenging. So it's scope 1, 2, 3, basically. So it is a very challenging figure, and there's only a couple of suppliers globally that can meet that right now. But I think what's important is for us to set out those ambitions and that direction of travel. So the way we're managing at the moment is we're working with forward-thinking suppliers who have a credible action plan to get to 4 tons or lower, and those are included in that as well as part of this journey. But what we wanted to show was this is where we think we need to be. And that figure, to be honest, that's only going to get smaller. But the emphasis, I hope, was clear in the presentation that we want to drive up the recycled content. That gives us loads of benefits, which you all know well, you know, in terms of not only the CO2 side of things, energy reduction and you know, sort of resilience in general, lower impact on the environment and people. And then when we have that primary side, it's just saying let's squeeze that, but let's make that as lower impact as possible. Yeah.
Right. There was a question first in the back. Yes.
Hi. Thank you for the presentation. I have a question. So you said that I understand the point that you're not the one producing the material, but I would understand that you somehow, especially if you want to increase the recycled content, that you can do some actions in order for the dismantling, that it can be easier taken apart and that it can be recycled afterwards, so that the recycled material comes back to you. And then I think that's the same point. So for the traceability, so that you showed it there on your last slide, you say that it's necessary to have a traceability from the source to the car, but wouldn't that actually go further so that you also give the traceability further, because you're right in the middle of the chain, so also to the dismantler, and especially now coming up with a digital product passport and around this topic. So I would just be interested in how these factors actually play a role in the company, like design for recycling, but then also giving like information on the material content and possibilities to dismantle the car further along the chain from your side.
Okay, so first of all, I think it seems like we need a chat in the break because this is a big topic. So let's do that. But to sort of give a general answer to this, yes, we are working, as I say, at a component level with design for recycling, design for disassembly. We've been doing remanufacturing since the 1950s, basically, and we're looking at how to expand that across the range of components. So it's not just about end-of-life shredding, for example, it's through that value chain. Your point about traceability, you're right, we are a point in the value chain, and we need to construct all of that together, which comes back to my point around collaboration. We are just one link in that chain. If you like, a steward of the material for the period that it's in the car, and we take that seriously, but we need to at the same time understand where we need to focus our efforts, and right now it's on that portion of the supply chain. So we need to be able to say, where is it coming from? Can we quality assure that, and then can we be clear about what is in our car as well? So I think that's the first step, and then, as you say, we need to close that loop around. But please, let's talk afterwards. You had interesting questions.
I will join this talk, and we have time for a last question.
We know that Volvo is currently installing gigacasting capacity for aluminium in Sweden. Is that already integrated in your outlook, and how you see personally the recycling issue for gigacasting parts?
Yeah, so I can, yes. So I was part of the core team for that, and I led the material development for the mega casting. So the foundry, for those of you that are not aware, we have the largest permitted capacity in Scandinavia with the foundry that we're putting into place now. So we'll be casting the entire rear floor of the vehicle to start with. And the development of the alloy, we were thinking strongly about energy consumption, about access, about recycled content, and trying to drive it from a first principles perspective from the very beginning, from day one, and also looking at the cost structure to ensure we have profitability. So yeah, it's baked in.
Thank you very much, and thank you for answering to all these questions. Maybe a last round of applause for Simon. Thank you very much.
Thank you very much. Thank you. On to the next.
Thank you. And picking up one of the sentences that Simon just said, Volvo Cars is just a part of a chain in the automotive sector. This is a perfect smooth passage to the next speakers because they will join us. They will join me on the floor now to talk about Catena X. Actually, Catena is the Italian translation of chain, and Catena X is an initiative in the automotive value chain. Was one of the main objectives is to set up an ecosystem to transfer information along the value chain. So it's my pleasure to introduce you to Carolin, Tröster, and Cagdas, Tekin. So they are here both together speaking on behalf of Catena X, but they are affiliated to different companies. So Cagdas is project engineer at BMW, and Carolin is expert business consultant at E-System. So I will leave the floor to them, and I think that you will also maybe address one of the questions raised before, right, about the digital product passport. So thank you for being with us, and the floor is yours.
Thank you very much for having us. I hope I'm well audible on this. If that's not the case, reach out anytime to me. So the curious thing is there are lots of parallels to sessions we had before today. My name is Cagdas Tekin. As introduced, I'm a project engineer working on digital twins in a digital vehicle file team at BMW. And also, I'm active in the Catena X consortia, where we are tackling various challenges, and especially working on technical data structures and data vessels to be shared across the whole ecosystem, no matter what kind of company it is, unless it's in the automotive supply chain. As Catena X, we see various and ever so important challenges which companies all across the globe currently are facing all together. Oh, it works, nice. One of these challenges, we heard it before, is the supply chains being prone to disruptions, be it for geopolitical, economical, or natural causes. And at the same time, companies strive for sustainability, requiring them to rethink, reassess, adjust their processes and supply chains in order to be able to achieve and also sustain their own sustainability goals. This requires an extensive amount of data to be exchanged in a collaborative manner and potentially globally and also decentrally organized data. And unfortunately, decentrally organized and global data exchange also correlates with complexity, which then in turn again requires companies to invest into innovations and technologies, thus leading to high costs of innovation. No market player can solve all of these challenges at once on their own, and the key word here is collaboration. As Catena X, it is our motivation to meet these challenges in a collaborative manner, meaning that enabling participants of the whole automotive industry value chain to compliantly collaborate together, share data in a same global and open data space. This includes tier N suppliers, material suppliers, components, system suppliers, as well as OEMs, even the end users, for example, the buyer and driver of a car, and in the seemingly end of the other side, also dismantlers and recyclers. Hence, it is one of the key characteristics of Catena X to ensure interoperability. This means that any ecosystem participant, no matter what kind of product they produce, is able to use the same technology, the same measures, the same data models, the same implementations in this data space, which the other participants as well use in order to be able to communicate with anyone and in order to ensure that the decentralized data is shareable with anybody in the same way. Initially, the consortium was kicked off with 10 use cases, which directed to the value contribution. And as you see, our today's focus, circular economy, is only one part. The scope of topics in Catena X is huge. And this has started in 2020 with the initial concepts. These have been developed and refined iteratively until today, still in progress. And we met one large milestone in 2023, October, when the first operating company based on the Catena X ecosystem went live, and thus the first real use cases went live and the real data exchanges between companies participating in the ecosystem. And since then, it is growing iteratively, and the goal is, of course, to get as many players as possible, since the ecosystem lives from the number of the participants and its variety. In August 2024, the consortia, which was kicked off then, will end. So we also are almost reaching our final event soon as Catena X. But the work doesn't stop there. Dedicated expert groups will take over the work and still develop and improve the ecosystem, maintain the ecosystem with upcoming product passports, etc. So it is hopefully a never-ending story, which is improved and improved. So I mentioned data spaces pretty often now, and a data space is simply that space without data being sent across the ecosystem and shared between the participants. Arguably, the most important vessels to share the data are digital product passports. Since we have a variety of different companies in the value chain, everyone must be able to speak the same language, also in a technical way. And this language is the digital product passport, which bundles following requirements or use cases and benefits. Of course, digital product passports allow the fulfillment of regulation once they went live in the said company and are shareable. And the regulations, they keep coming, as we all know. At the same time, digital product passports provide extensive transparency for a product, from static data such as the size, weight, etc., data which is not prone to change, as well as health state data, which is bound to change during the in-usage phase, and also including, of course, material contents and recyclates, hazardous substances used in a product, in order to be disclosed and later also potentially be used in business processes, such as a dismantler later deciding which dismantling process would be the best one for a given product based on the information they receive from the passport. And in the end, of course, what I mentioned in the beginning already, utilizing a standardized exchange possibility for all of the participants. These digital product passports today are actually well described already by authorities. I think most of us know the ESPR regulation, or its proposal at least, with the generic digital product passport, which we are currently working on and developing. And then we have the battery passport, the first tangible product passport, which comes into force in February 2027. By then, requiring many companies, requiring OEMs, automotive OEMs, to issue a battery passport for each of their battery electric or plug-in hybrid electric vehicle, which uses a high voltage battery. However, digital product passports are not simple data records. They are not just a collection of data, which is then pasted into a data system and queried whenever we use it. There is a logic behind it, which then, again, is enabled by Catena X. These digital product passports will be shared in the whole ecosystem. This means that they touch different times of data being created and different life cycles. Hence, there must be some logic which allows the digital product passports not only to be queried and read or ingested by different parties, but also to allow a permissioning and a controlled disclosure of the data, upholding trust or confidentiality rules, and making sure that each party sees the, for him, relevant data. If we turn these previous explanations into a graphic, this is what comes forth. This is the circular economy imagined and currently being developed on in the Catena X consortium. Let's just imagine that all of these regulations pertaining to product passports went live. In that case, the scenario would be that an institution, a tier N supplier or an OEM, which brings a product onto the market, has to issue the passport and has to share it among different parties. If we look at the graphic clockwise, this would mean, for example, an OEM, in our case a battery passport later, would be issued, and the end user buying the car will be able, by simply grabbing the smartphone and reading a QR code, to read the health state data which he is allowed to see through the battery passport. the same battery passport, once the product or the battery goes end of life, is also queryable by a dismantler receiving the battery to dismantle it, and then also having access to more extensive data, such as dismantling instructions, material quotas, and contents. Later on, once we reach the recycler, a certificate of destruction will be issued, which then, with a certain time offset, will also lead to the deletion of the product passport. However, the data flow does not end here. Once a recycler did his job in that regard and fetched the data necessary and, for example, updated data to recycled content 1 from the recycling measures, this data is also shared in the ecosystem again and later on will flow into the next product passports and the next products. This ensures that through digital product passports, we have a circular and up-to-date record of the data and can disclose our sustainability goals in the whole ecosystem, no matter which type of company it is, as long as it is in the ecosystem available. So this is all theory, of course. We put a lot of it into practical motion and already have standardized data models. More of that will be told to you, explained to you by my colleague Carolin.
Thanks. Thank you. Well, yes, as mentioned, we do have some practical results here. One thing I will not present here are all the, I think these are the bigger part of Catena X, all the technical results regarding the network, the data spaces, the connectors, the validation, and how all of these things work. We are directly focusing on one of the presented 10 use cases, the circular economy one, and even there we are just kind of a small part there regarding the digital product pass. So even the results we present here, and you see here on the left side a screenshot of the battery pass application viewer, which was developed through Catena X, is reusing or using and is based on all the Catena X network and connectors to be functioning. Yes, maybe, but as a start here, it's mentioned battery passport, the first tangible DPP 4.00, so the first digital product passport. And this is also the first one we started with at the beginning of Catena X. So even in 2021, we thought, yes, battery, that's it. That's a first one we need to address. Well, the reason for that one was especially because of the regulation. As mentioned, it's in force in 2027, but it's kind of already there since February this year. So technically, it's already there and it's finished, the regulation. So until 2027, the suppliers, the OEMs, whoever issues a battery passport has to be prepared till 2027, but they can already start. Later then we followed with the DPP, so the digital product passport. We started with something specific and then got the general one, especially because the ESPR regulation is kind of in a proposal state, so we are kind of guessing here what is really required from a supplier, from an OEM, or whoever provides the data. And we also added a lot of product-specific passports where we tried out how a DPP for a specific product could look like. And there we also found the kind of like the match between a digital product passport and the battery passport, so between the two requirements from the legal side. On the right side, it's kind of like a simplistic version what we want to include, or not what we want to include, but what the regulation requires you to include. I wasn't allowed to show the picture of the data model because it's quite big and it would be too complex to show here even on the big screen. It has, and I counted it yesterday night, 300 data points, only the battery model, and the digital product passport has 150. But they're not to be too shocked from the number. There it's including all the flags, the timestamps, and so on. So it's not that big, but it's kind of complex as well. And maybe to highlight here why the digital product passport or the battery passport are important also in this round is 1/3 of these data points are only regarding materials. So 1/3 is regarding hazardous materials, active materials, critical materials, and all the information needed there. So in both cases, product and a battery passport, both are highly focusing on material one. The other thirds are, one is, in the battery case, it's 1/3 for performance values, which are, they are highly important from the directive, and the other third is more general information regarding manufacturing, import, sustainability information like the product carbon footprint and something like this. To go to a more practical result, what we really can use as someone who is not in Catena X, and as mentioned, Catena X is coming kind of like to an end. We do have the kits, the so-called packages, where someone who wants to start with the use case of a digital product passport can reuse all the things which are open, and the keyword open here is key. We do have the application, the data models, the process description, all of these things are open. The application is even open source. So you can reuse and use all of these things and read into them, also process descriptions, how you can start with a digital product passport. A few of these things are marked with a Catena X logo. These are included in a digital product passport use case standard, and there are even more standardized. Maybe to mention here on the right side, there's also the material pass. This is one of the kind of like newer topics in our use case, where we kind of try out how a product passport for a material could look like, because there are very specific things which are necessary for material passport, but there we have a lot of support from our Catena X team, and we have, and I think the next slide shows best. Oh, no. The one after that one, maybe that one. We do have a variety of partners in Catena X, and there especially are our material suppliers who are kind of pushing the topic of a material passport as well, to kind of track and make the traceability through for materials as well. That one after this one would be my last slide. As mentioned, we started 3 years ago, roughly, and with the yellow bubble, the Kickstarter project, the consortium, which is coming to an end, but only this part is coming to an end, so all the other parts are still in place, and the operating company, which was mentioned, is to the bottom right side, the Confinity X. It's an, as mentioned, a joint venture of 10 different companies, to support and to onboard companies who really want to use it. And the association is also still in place, which is providing standardization, certification, and the complete network and data spaces. But maybe one last sentence, and this is also kind of like the call to action. The development area is still there. The data models, the standards, the use cases can be further developed, and there we would like all of who can join, for example, to these expert groups, to really work there and kind of further develop all the things which are done here. Yeah. Thank you.
Thank you very much for this presentation, also very interesting. Let's see, is there any question for our Catena X representative today? Yes, please. Microphone is coming.
Hi, Christina Meskers from Sintef in Norway. We've been thinking, you mentioned the recycling part of the digital product passport. Can you tell a little bit more on how you operationalize the digital product passport at the end of life, and then with this recycled content going to the next passport?
Yes, so the digital product passports generally have different categories of data which adhere to every participant of the ecosystem, including recyclers or dismantlers. And some of the data includes specifically, also required by the ESPR for the generic digital product passport, how to dismantle or build out or get out a component out of a product. For example, the high voltage battery, to build it out successfully from a battery electric vehicle. And then how to further dismantle the battery into smaller and smaller parts. This is specifically required, and as an OEM, we will be obliged to provide these information and disclose them to a recycler. This means that, for example, if the recycler receives a batch of to be recycled products, that they will have a data carrier, for example, a QR code or RFID, and they will be able to read it and then fetch the data as a member of the ecosystem. And then they have access to the instructions without having to persist them on their side. So it's a decentralized data exchange on demand, happening on demand. And then they will be able to continue or kick off the dismantling process for these specific products. Meaning that, just a scenario, if you get 10 different batteries per day, then you would obviously get 10 different battery passports, and hence for each of the entities, each battery, you will get the correct dismantling instructions without having to do an own research or without having to maintain your own catalog.
That's not exactly my question.
Oh, sorry then. Please come again.
You mentioned that when we're speaking about recycled aluminum, for example, that in the end, while you shred a battery casing or something, it goes to an aluminum remelter and all our QR codes and everything disappears. You have the certificate of destruction.
Correct.
So we basically lose the connection to the original DPP. But you mentioned that you would use like recycled content information and everything in the new life cycle of the DPP. And I was wondering how that works in a little bit more detail.
Okay, got it now. So after digital product passport has been deleted, there is a grace period to delete a product passport upon receiving a certificate of destruction. And it is correct that the digital product passport is gone because the product is simply gone, and the passport lives alongside the product in all life cycles. However, the companies are still interconnected in the ecosystem, and aside from the digital product passports, it is still possible to exchange custom data portions with each other, using the same mechanisms which are also used to send a digital product passport across the ecosystem. This means that a recycler will not have to re-implement an interface, because there is already an existing interface, but they're sending different data this time. For example, the amount of recycled content won back. So that's why it's a loop, and the data transfer is not stopping at one point. However, the medium with which the data is transported, that indeed changes, because the passport is not existing anymore. Could I answer your question this time? Okay.
Thank you very much. Any other question from the audience? Yes?
Thank you for your presentation. Did you consider any intellectual property rights issue? And if you did, how did you solve?
No. Catena X, I mentioned it before, that it is an open data space, and Catena X specifically thrives through an open source open source doctrine. So, for example, the data models of the battery passport and many other data models aside from passports for other data exchange topics are all available publicly and can be looked into.
Yes, but maybe the company does not like to have to disclose how the battery, for instance, has been made.
I think there the decentralized approach is coming in. So even if these data models are only the language and the structure, how or what you want to exchange with each other, but the data itself will stay at your place. So it's not like you're uploading your real data to Catena X. So it stays there, and only Catena X is used as a registry, how to connect with each other. And describes also how the exchange should look like and is standardized there, but the data itself stays at your place. So it kind of like still direct where and who can see this information.
Thank you very much. Thank you again for joining us. Maybe a last round of applause.